Firstly, I'd like to give an apology for not uploading last week. I had set myself the goal of uploading once a week as regularly as clockwork, and if this channel gets to be any substantial size, that will become absolutely essential. However, this week has been a particularly busy one. As of recording this, I only have 3 subscribers, one of whom I happen to know is my mother, so I trust that by missing a week I haven't inconvenienced too many viewers. I can only state that I will try harder to stick to the original goal in future. Right, apology over. On to this week's sample program. Creepy Crawly is a simple JavaScript expert system which, as you can probably tell from the name, lets you identify creepy crawlies by asking a series of questions. You know, ants, spiders, wasps and so on. I considered which field of expertise to use in the example, but all the useful subjects, such as diagnosing health problems, might lead to me being sued if the expert system makes a mistake. I don't know enough about those fields to make a convincing expert system that can produce useful results. On the other hand, I didn't want to use the tired old example of just getting the expert system to identify animals, such as distinguishing between cats and dogs or lions and tigers, so I chose the middle path of creepy crawlies. Having said that, I don't know that much about creepy crawlies either, so there might be factual errors in the logic. Please feel free to put those right. On to the program itself. The only thing of note on the screen is a division called report, which tracks the progress of the logic as the programming progresses. The function add takes a piece of text and adds it to the string, which is then used to fill the inner HTML property of that division. You will see add being called at various points in the program, simply to place an appropriate message at the end of a long list of such messages to keep the user in the loop. The string s, of course, has to be a global variable, so that it persists throughout the program run. Here are the other global variables that I use. The variable allDone controls the program in a large loop, repeatedly processing rules or asking questions. AllDone is only set to true when either the bug has been identified or it has run out of rules. The identity of the creepy crawly is stored in the variable identity. It is set initially to an empty string to indicate that we don't know what the thing is. The variable ans, or ans, is used to store the answer temporarily whenever a question is asked, and numeric variables are set up for yes, no, and don't know, simply for convenience. As stepping stones to identifying the little beastie, the program sets up various qualities, such as whether it has wings or counts as big, which for this program means bigger than a centimetre. Of course, these qualities relate specifically to creepy crawlies, and they are all set up initially as don't know. 2 arrays are set up which contain the main part of the logic. The first of those is condition, which contains the conditions that trigger each of the rules. You will recall that the rules in an expert system have 3 parts: a condition that has to be fulfilled for the rule to be activated, a priority level which indicates which of many activated rules actually fires, and a consequence part which controls how the rule affects the knowledge base, setting the qualities to yes or no, ready for other rules. There are 22 rules in this expert system, some of which are questions, and there's no way I can show the entire array on one screen, so I've only put up the first part. Rule 0, for example, will only trigger if the value of the variable wings is don't know, i.e. -1. The array priorities contains a priority level for each rule. Higher priority rules take precedence over lower priority ones, but this only applies if more than one rule is triggered. In general, I give rules that ask questions of lower priority, the ones in the array, so that the expert system only asks questions if it can't do any logic for itself. You'll find, if you examine all the conditions and priorities, that the rules seem to be in a haphazard order. Quite correct. The fact that they can be ordered by priority level means they can be included in the arrays in any order you like. I just put them in as and when I thought of them. The variable numRules contains the number of rules, automatically determined from the length of the condition array. Whenever a rule fires, it dies, and is marked as dead, so that it can't be activated again. This prevents endless looping, as well as making the program more efficient. The array ruleDead contains a Boolean value for each rule, initially false. The entire work of the expert system is carried out by a huge loop in function runEs, which is called by the start button on the screen. This loop runs continually until the variable all_done is set to true. The first stage of each run through the loop is to determine which rule, if any, fires. This is stored in the variable which_fires, initially set to -1. Each rule is then tested to make sure that it's not dead and if its conditions are met. This is achieved using a rather neat trick built into JavaScript, i.e. the Eval function. You've probably used this to turn a string containing a number into an actual number, but it can also cope with variable names. That's why the conditions in the array were all cast in the forms of the sort of thing you'd see in an if statement. Eval takes each string, evaluates it with all the variables, which can be yes, no, or don't know, and produces a value which is either true or false. Assuming that a rule is still alive, and that the qualities are set so that the eval condition passes, its priority level is then compared with the highest one so far, also initially -1, so that even the lowest priority rule stands a chance of firing. If we have a new winner, then which fires is made to point to this one and the highest priority is updated. When this inner loop terminates, which fires will either point to the highest priority rule that is capable of firing, or it will still be -1, in which case not a single rule came up trumps. The second part of the loop is a massive switch statement, with a specific action for every rule. Again, I've only shown 3 of them on screen. Look at the code itself to see all the rules. The value of which fires picks which rule to fire, and of course there's no need to test the conditions of that rule again. The fact that which fires points to it means that it has already passed the test. You'll notice that the last clause of the switch statement is a default, which only triggers if which fires hasn't been set to any rule. This clause sets all_done to true, to indicate the main loop must end, because the expert system is out of options. After the switch statement, the rule that has fired is marked as dead. If the variable identity has been set to something, then the creature has been identified. If which fires is still -1, then there are no more rules that can fire. Either way, the loop is over and the program is over. That closing bracket is the end bracket of the large while loop that you saw a couple of slides back. And after the while loop has terminated, the program adds one of 2 final messages to the screen, either identifying the creature or admitting failure. Let's examine 2 rules in turn. Firstly, an ask rule, then a logic rule. You are looking at the code for rule 2, which asks whether the creature has large compound eyes. Bugs like flies and bees do, but others like spiders and butterflies don't. The condition for rule 2 is that the variable compound eyes is don't know. If it has been determined already that the creature either does or doesn't have compound eyes, then this rule mustn't fire. If the rule fires, the function ask is called, with the question, does the animal have large compound eyes? The Boolean parameter after that is set to true to indicate that this question has a yes-no answer. There is one question, asking how many legs the creature has, that isn't a yes-no question. Function ask returns the values yes, no, or don't know, and whichever one is returned, the variable compound eyes is set to that. I've compressed the function ask slightly to fit it on the screen, but it basically uses the JavaScript prompt statement to get an answer from the user. The prompt box always provides a cancel option, returning the value null, and this is used to indicate don't know. If the question is a yes-no question, and the user types y or n, then the function will return yes or no. Any other answer, such as specifying the number of legs, is simply returned as is. Let's look at Rule 10 for an example of a logic rule. The condition for this rule is that the creature must live in social groups, but cannot be brightly coloured or multicoloured and can't have wings. In this case, we have identified the creature as an ant. Okay. I know that ants do have wings during the swarming season, but I've tried to keep things simple. So bite me. Unless you're a red ant, of course, because red ant bites really do sting. Something to do with formic acid, I believe. And that's it, pretty much. The program itself is actually considerably easier than some of the ones I've produced for this channel. And, unusually, the majority of the code is actually the logic of the AI problem itself, rather than the behind-the-scenes stuff that keeps the whole thing running. And this proportion will only increase if you add more rules and logic. That's my first suggestion. I'm sure you can think of dozens of horrible Crawly things that this simple effort fails to identify. How about adding in rules that would distinguish between butterflies and moths, between grasshoppers and locusts, or between the countless types of flies that you could meet? Or better still, use the framework that I've given here to produce a more useful expert system, perhaps something that diagnoses faults in car engines, or even medical conditions in the human body, if you feel confident about doing so. I'd be interested to hear about what you can do with it in the comments below. One feature that I didn't include was the explain facility that lets the user ask, "Why are you asking me this question?" We needed to know how many legs the beastie had to distinguish between insects with 6 legs and arachnids, like spiders and ticks, with 8. I'm sure the user would have appreciated being able to get hold of this information. Another possibility that you might like to include is degrees of uncertainty. Granted, you could answer "I don't know" to any question, but what happens if you think the answer to a question is yes, but you're just not that sure? It's like those wretched ants, which have wings at certain times of the year, but not at others. This brings me neatly onto the theme that we will be tackling next week, that of including uncertainty in decision-making in programs, like expert systems. Keep watching this space, ladies and gentlemen. And of course, the final suggestion is always the same for each of these videos. Don't forget to click on that like button, leave a comment below, and for the love of God, please click on the subscribe button. I mean, I've been at this for weeks, and I only have 3 subscribers. I won't go on about it anymore, so can I just say thanks for watching.